Assalamu alaikum and welcome to Cambridge Chemistry channel with sarwatAhmed. Today I will solve paper 5 for A level 970151 October November 2023. So let's start. The concentration of dissolved oxygen in a sample of water can be measured using the following methods. Manganese hydroxide is oxidized by oxygen dissolved in a sample of water to form manganese 3 hydroxide. Oxygen plus manganese 3 hydroxide, manganese 2 hydroxide plus water to form manganese. So this is oxygen is there and water is there to form manganese 3 hydroxide. Manganese is going to oxidize to form from Mn2 to Mn3. The manganese 3 hydroxide then reacts with iodide ions to produce aqueous iodine. Now this manganese 3 hydroxide react with potassium iodide to form manganese chloride and iodine. Iodide is going to oxidized. So manganese 3 hydroxide act as an oxidizing agent and potassium iodide act as a reducing agent. So manganese 3 hydroxide, manganese 3 ions is going to oxidize iodide ion to iodine. So and itself is reduced from 3 plus to 2 plus. The amount of iodine produced is proportional to the amount of dissolved oxygen. So iodine is equal to the directly proportional to the oxygen, dissolved oxygen. 25 centimeter cube of the solution containing aqueous iodine is transferred into conical flask and titrated against 1 into 10 raised to minus 3 mole per dm cube sodium thiosulfate. Iodine plus sodium thiosulfate to form Na2S4O6 and plus sodium iodide. Iodine is going to reduced and sodium thiosulfate in this reaction sulfur is going to oxidized. Complete table 1.1 and determine the mean titer to be used in calculating final burette reading, initial burette reading and the trial run, experiment 1, experiment run 1, run 2 and run 3. So this is 27.3 and initial reading is 0.00 and run 1 28.10 1.10. So 28.25 1.55 and similarly initial reading is this. Now the titer per centimeter cube is 27.30 and run 1 is the 27 and run 2 26.70 and over here 26.80. So the mean titer value is 26.75. 26.75. So these are the best titration by 26.70 plus 26.80 divided by 2. So we get mean titer is 26.75. Calculate the concentration of dissolved oxygen in the 25 centimeter cube of solution. So first calculate the mole of sodium thiosulfate, that is equal to 26.75 mole in this volume in 1000 dm cube into 0.001. So this is equal to, this is the concentration of sodium thiosulfate and this is in mole per dm cube. 26.75 in so the mole of sodium Na2S2O4O6 Na2S2O3. So this is the mole of 2.675 into 10 raised per 2 minus 5. So moles of oxygen is, we have 4 is to 1 ratio, 4 is to 1 ratio. This is moles of oxygen is 1 and moles of manganese is 4. Mole per dm cube. So this is ratio 4 ratio 1. So we have moles of oxygen is 6.68 into 75 into 10 raised per 2 minus 6. Concentration is 6.6875, and we know that 25 centimeter cube of solution containing iodine is transferred into a conical flask. So concentration is equal to mole over volume into 1000. So this is the concentration of dissolved oxygen in 25 centimeter cube of solution is 2.675 into 10 raised per 2 minus 4. Suggest a suitable piece of apparatus for the transfer of 25 centimeter cube of the solution containing aqueous iodine. 25 centimeter cube is measured by using volumetric pipette. Water samples are collected in full sealed flask. Explain why sealed flask must be completely full. To avoid any oxygen from trapped air in the flask reacting with manganese 2 hydroxide, that is act as an oxidizing agent. The concentration of oxygen in water at different temperatures is shown in the table 1.2. The concentration value is missing for 25 degrees centigrade. So these are the at 25 degrees centigrade. So 0, and this is equal to, you know that by using graph, this value is at 25 degrees centigrade, the value is 2.55 into 10 raised per 2 minus 4. So this is equal to 2.55 into 10 raised per 2 minus 4. At 4.58, 5, 3.97, 10, 3.20, and 15, 3.3. By plotting this graph, plot a graph of concentration of oxygen x y-axis against temperature on the grade. Use a cross to plot each data point. Draw a smooth curve of best fit. So this is the graph, and 2.50 into 10 raised per 2 minus 4 over here. So this is use the graph to reduce the concentration of oxygen at 25 degrees centigrade. Concentration of oxygen at 25 degrees centigrade is 2.55 into 10 raised per 2 minus 4 mole per dm cube. Circle the most anomalous point on the graph. So this is the most anomalous point. The actual temperature is suggest an explanation for this anomaly. Assume that there was no error in measuring oxygen concentration. The actual temperature is more than recorded temperature, so that's why when temperature is higher, lower the solubility rate. So actual temperature is more than recorded temperature. So this is all about the question number 1. Question number 2. Benzene disonium chloride decomposes in water as shown in the following equation. So this is benzene disonium chloride plus water. So this is decomposed to form phenol plus nitrogen plus HCl. A solution of 0.0750 mole per dm cube decomposes at a constant temperature of 50 degrees centigrade. The volume of nitrogen gas collected is released every 5 minutes for 45 minutes. Draw a label diagram to show how the apparatus could be set up to carry out this experiment. This is the apparatus of this experiment. Water bath is used to maintain the temperature or control temperature at 5 degrees centigrade. So conical flask with delivery tube and gas syringe. This is a conical flask. Label the whole apparatus. and this is gas syringe, graduated gas syringe. So this is water bath to maintain the temperature or control temperature 5 degrees centigrade. Using the method, a student obtains the graph shown. So these are the graph, the half of the concentration. Okay. So on figure 2.1, draw tangent to the curve. T is equal to 0. Minute, calculate the initial rate of reaction in centimeter cube minute inverse 1. So that is dy by using dy dx, 35 centimeter cube divided by 3.5 minute. 35 centimeter cube. So drawing tangent over 1, 2, 3, 35 and half of the concentration volume, 35 over 3.5 minute. So draw tangent from 0, 0.0. So I don't have scale. So use any coordinate at this point. So I use 35 centimeter cube delta y coordinate, and one coordinate is under 5, that is 3.5. So these are two coordinates dy and dx on tangent. After drawing tangent, take any point. So according to my point, this is 35 centimeter cube divided by 3.5 minutes, that is equal to 6 point. Initial rate of reaction is 6.60 centimeter cube per minute. Explain why the initial rate of reaction is calculated at t is equal to 0 minutes rather than dividing the total volume of gas produced by the time taken to produce it. The total volume of gas produced divided by the time taken is the mean rate or average rate rather than the initial rate. Describe how the curve in figure 2.1 would be different, if at all. If the atmospheric pressure increases, all other conditions stay the same. The curve would be lower than the initial graph. So we know that atmospheric by increasing pressure volume is decreased and PV is equal to nRT, or which is constant. It is constant. So if the atmospheric pressure increases, all other conditions stay the same. This is the constant value. We know that PV is equal to nRT. The curve would be lower than the initial graph if the atmospheric pressure increases. On the figure 2.1, draw a second curve to show the graph produced if the same volume of 0.0375 mole per dm cube decomposes at a constant temperature of 50 degrees centigrade. All other conditions stay the same. So this is the half of the concentration decomposed. So this is the half of the concentration. So the total is this 55 volume. This is the half of the concentration, that is the used. Half of the concentration or volume of the half of the volume nitrogen is. If reduce half of the concentration, then half of the volume of gas is produced. This is nearly equal to this is 55 and that is nearly equal to 25 volume. So this is nearly equal, half. Another student investigates the effect of changing the concentration C6 phenyl diazonium chloride aqueous at 50 degrees centigrade. He measures the time taken to collect 0.0150 dm cube of nitrogen and calculates the rate of nitrogen produced by dividing 0.0150 dm cube by the time taken. The results are shown in the table 2.1. Rate, we know that rate is equal to concentration divided by time, and 0.500 is the initial concentration divided by 21. 21 is the time taken, and this is the concentration. How to calculate this rate of nitrogen produced dm cube, second inverse 1. So this is how to get this value, concentration over time. So this is equal to 7.14 into 10 raised power to minus 4. This is equal to 4.55 into 10 raised power to minus 4. So we know that so complete 0.200. Complete the table to calculate the values for the rate of nitrogen production. Give your answers to 3 significant figures. So you know that in this way 0.200, 0.40, 0.30 and 0.200 divided by 0.11, and in these are the rate of nitrogen production. The reaction is first order and obeys the following rate equation. You know that if by using these two values and two rates, so 0.200 divided by 0.100 by increasing the concentration, by reducing the concentration, half of the concentration if we reduced, half of the rate is decreased. So that's why this is the first order reaction. Explain how the data in table 2.1 support this statement. By doubling the concentration, rate is doubled, like 0.100 to 0.200. When concentration is decreased, rate is also decreased, hence, and 0.2 to 0.1 rate is also doubled. Time taken to collect 0.0150 dm cube of iodine. State the dependent variable in this investigation. That the time is on x-axis. On our x-axis is the dependent variable. The student wants to perform similar experiments using 0.200 mole per dm cube for the phenyl diazonium chloride. Describe how student should make a standard solution 100 centimeter cube of 0.200 phenyl diazonium chloride, starting from a solution of 0.500 mole per dm cube. Give the name of and size of any key apparatus which should be used, and describe how the student should ensure the volume is exactly 100 centimeter cube. So first, calculating the volume of volume is taken in flask. So we know that C1 concentration of reactant 1 and concentration of reactant 2 and volume of 1 and volume of 2. 0.5 into 10 raised power 2. This is the starting from a solution of 0.500 into volume. So we find out the volume of this starting material, and we know the volume of 0.200 into 100. We make this solution up till 100 centimeter cube. So V1 is equal to 0.2 into 100. By cross multiplying, we get the volume is 40 centimeter cube. So in this way we can find out the volume of the second reactant. Use 50 centimeter cube burette to take 40 centimeter cube of 0.500 mole per dm cube C6H5N2Cl in 100 centimeter cube of volumetric flask. Top up the solution to the mark with distilled water and shake the flask to homogenize the solution after stopper. Explain why Step 4 must be carried out at temperature below 5 degrees centigrade to make sure concentration does not change, because diazonium chloride decomposes above 5 degrees centigrade. Diazonium chloride, benzene diazonium chloride is used in the manufacture of synthetic dyes. A student prepares a sample of the dye using the reaction scheme shown in figure. So this is phenylamine, and plus in step 1 NaNO2 plus HCl to form HNO2, which react with this compound to form N2Cl, and then by reacting benzene phenylamine to form this compound. In step 1, phenylamine is converted into phenyl diazonium chloride, and in step 2, phenyl diazonium chloride is reacted with more phenylamine to produce the solid dye, which is then filtered. The students' final dye yield was 52%. They had not spilled any reagent or products. Suggest 2 reasons why the students' yield was lower than 100%. Assume no errors were made in the measurement of any substances. Reason 1. Some phenyl diazonium chloride had decomposed or reacted with water before reacting phenylamine or temperature above 5 degrees centigrade, causing decomposition. Phenylamine used was impure, so reaction 2, same dye is left on filter paper or dissolves in filter paper. Explain why the solid dye should be dried before assessing the melting point. The presence of water in solid dye will affect the melting point of the solid, so hence why the solid dye should be dried before assessing the melting point. So this is all about this paper. Hopefully you understood this paper. If you understood, then like the video and subscribe the channel. Okay, happy learning.